Energy from space, sci-fi or reality? China's breakthrough explained. Imagine generating electricity, not from coal, not from wind, not even from solar panels on Earth, but from space. What if the energy powering your home one day comes from satellites orbiting thousands of kilometers above the planet? Sounds like science fiction, right? But what if I told you that China, along with other space agencies, is already working seriously on this idea? Now let's talk about China, because this is where things get interesting. China has publicly announced plans to build a space-based solar power station by the 2030s. Chinese researchers have already built ground-based test facilities, tested long-distance wireless energy transmission, designed modular space solar stations that can be assembled in orbit. What is space-based solar power? Let's start with the basics. Space-based solar power, or SBSP, is a concept where solar energy is collected in space, usually by large satellites, and then transmitted wirelessly to Earth. In space, solar panels have one huge advantage: no clouds, no night, no seasons. A satellite in orbit can receive sunlight almost 24 hours a day, unlike solar panels on Earth that stop working at night or during bad weather. The idea itself isn't new. Scientists started discussing it seriously in the 1960s, and NASA studied it during the space race era. What is new is that technology is finally catching up. So how do you send energy from space to Earth? You don't use cables, obviously. The process works in 4 main steps. First, massive solar panels in space collect sunlight and convert it into electricity. Second, that electricity is converted into microwaves or laser beams. Third, the energy beam is sent safely toward Earth. And finally, special receiving stations on the ground, called rectennas, convert that energy back into usable electricity. This isn't theoretical anymore. Wireless power transmission has been tested successfully on Earth and in space experiments. The real challenge isn't if it works, it's how efficient, safe, and affordable it can be at large scale. Now let's talk about China, because this is where things get interesting. China has publicly announced plans to build a space-based solar power station by the 2030s. Chinese researchers have already built ground-based test facilities, tested long-distance wireless energy transmission, designed modular space solar stations that can be assembled in orbit. This isn't hype. These projects are linked to major Chinese institutions and peer-reviewed research. China sees space energy as a long-term clean energy source, a strategic technology, and a way to support carbon-neutral goals. It's ambitious, but technically grounded. Let's address the elephant in the room. Is it safe to beam energy from space? According to studies from NASA, ESA, and academic research, the microwave energy density would be lower than sunlight exposure at noon. Aircraft, birds, and humans would not be harmed. Receiving stations would be placed in controlled zones, usually remote areas. In short, safety is a design constraint, not an afterthought. The real risks are not biological, they're engineering and economic. If this idea is so powerful, why don't we already have space power plants? 3 main reasons. First, cost. Launching massive structures into space is still expensive. Second, scale. These satellites would be huge, kilometers wide. Third, complexity. Assembly, maintenance, and reliability in orbit are major challenges. But here's the key point. Costs are dropping. Reusable rockets, robotics, and modular designs are changing the equation. What was impossible 30 years ago is becoming difficult but feasible today. If space-based solar power becomes viable, the impact could be massive. Imagine clean energy without weather limitations, power delivered to remote regions, emergency energy after natural disasters, stable supply for megacities. This technology wouldn't replace solar or wind, it would complement them. Think of it as a baseload renewable source, something green energy has always struggled to provide. So, is energy from space science fiction? Not anymore. It's still experimental. It's still expensive. It's still years away. But it's real engineering, real physics, and real research, not fantasy. China isn't alone. NASA, ESA, and Japan are all studying similar systems. The question is no longer if it's possible, but when it becomes practical. Energy from space might not power your home tomorrow, but it could shape the energy systems of the next century. And like many revolutionary ideas, it started as science fiction, before becoming science. If you enjoyed this deep dive into future energy technologies, don't forget to like, subscribe, and share your thoughts below. Do you think space-based solar power is the future or an expensive distraction? For a deeper explanation, you'll find the full article linked in the first pinned comment. Thanks for watching.